What is the difference between 1080p, 1080p and 1080i? Many times, I have seen resolution of 1080p and I know that it means 1080 pixels, but I also have seen specifications on some hdtvs to be 1080i. So, I want to know the exact difference between them and whether 1080i video quality is available for the laptops too. I googled and found out that at some sites, they mention 1080p rather than 1080p. Is there any difference between the two or they represent the same thing? Rev 1. Now I know that 1080p means 1080 horizontal lines of vertical resolution and a _p_ regressive scan video _.
I see a range of problems in the answers and comments here, even in some highly voted answers that provide otherwise very good information, that span from minor deficiencies that need explanation to some serious inaccuracies, so I think that some clarification is needed. The question is specifically, what is the difference between 1080p and 1080i? So I will start by outlining the main similarities and differences. I'll add some tips on how to choose the best format and then I will proceed to explain the problems that I found here. Some of the information presented below is adapted from my answer to interlacing on a computer monitor but is rewritten to strictly stick to the subject of the difference between 1080p and 1080i. Note: please note that this answer is specifically about HDTV and talks about signals and resolutions that can be transferred with a standard HDMI cable. Other resolutions and frame/field rates are certainly possible, but standard HDTV sets, game consoles, Blu-ray discs etc. use only certain resolutions and frame/field rates described below, or at least they did at the time of writing this answer. Specifically, this answer doesn't talk about ultra high definition television, super high vision, ultra HD television, ultra HD, UHD, UHD, 4K, 8K or anything beyond 1080p and 1080i that this question is about. Resolution. Both 1080p and 1080i have 1080 horizontal lines of vertical resolution, which with a widescreen aspect ratio of 16:9 results in a resolution of 1920 x 1080 pixels, 2.1 megapixels. It is not true that 1080i has a lower vertical resolution than 1080p. Frames versus fields. 1080p is a frame-based or progressive scan video where you are dealing with frames. You have frame rate and it is expressed in frames per second. 1080i is a field-based or interlaced or interleaved video where you are dealing with fields. You have field rate and it is expressed in fields per second. A field contains half of the lines of the frame, either even lines or odd lines, and if one field is composed of even lines, then the next one will be composed of odd lines and so on. Frequencies. 1080p has a frame rate of 25 frames per second for TV in PAL countries, 31.001 frames per second for TV in NTSC countries and 24 frames per second for cinematography. 1080i has a field rate of 50 fields per second for TV in PAL countries and 61.001 fields per second in NTSC countries. Note that it is not 30 frames and 60 fields per second for NTSC but actually 31.001 and 61.001, which is approximately 29.97 and 59.94, but the difference is important. Read about the NTSC color encoding on Wikipedia to see why. How to think about it. (1080p at 25 frames per second Imagine that you are shooting 25 pictures per second and storing them as bitmaps. Every frame is a full picture from the given instant. Every pixel in that frame was captured at the same time. 1080i at 50 fields per second. Imagine that you are shooting 50 pictures per second but storing only half of the bitmaps every time. Sometimes you store the odd lines and sometimes the even lines. Note that it is not the same as storing pictures with lower vertical resolution. Every field is a half of a full picture from the given instant. Every pixel in that field was captured at the same time. 50 halves does not equal 25 full pictures. Contrary to some comments here, interlaced video at 50 Hz does not mean that 25 full pictures per second are shown. It means that 50 halves of pictures are shown, but those are halves of 50 different pictures that were shot at 50 distinct moments of time in every second. You not only don't have 25 full pictures per second, you don't have any full pictures at all. Problems with 1080i. Interlacing causes a lot of problems. For example, you can't easily scale the video, rotate the video, make video slow motion, make video fast motion, pause the video, grab a still picture frame, play video in reverse. Without doing some tricks and losing quality, you don't get any of those problems with progressive video. In addition, the video encoding is harder because the codec never has a full frame to work with. Problems with 1080p. The drawback is that 1080p as currently in use has a frame rate that is only half of the field rate of 1080i, so the motion is noticeably less fluid. In fact, it's exactly twice less fluid, which is a lot. You can see it on large flat TVs that often deinterlace the video to be able to display it on their LCD screens, that, unlike CRT displays, are progressive in nature, which is the cause that they display picture of very high resolution but with jerky motion and some deinterlacing artifacts. Another problem is that usually 1080i is required for TV broadcasting, which means that 1080p is simply out of the question for some applications. Best of both worlds. Using progressive 1080p with 50 or 61.001 full frames per second in the future has a potential to eventually solve the above problems, but it will require a whole new range of studio equipment including cameras, storage and editing systems, so it probably won't happen anytime soon. The widely used ST standard for connecting HD video equipment doesn't have enough bandwidth. Currently, the only way to have a fluid motion with progressive scanning is 720p that has a frame rate that is 2 times faster than 1080p but the resolution of only 1280 x 720 pixels, instead of 1920 x 1080 pixels, which may or may not be a problem for some applications. There is no 720i. Conclusion: there is no one clear winner here. Update: here are some general guidelines to choose the right format. Is it for high-definition TV? Use 1080i or whatever is required. Is it for standard definition TV? Use 720p and then convert to 576i or 480i. Is it for internet and resolution is more important than fluid motion? Use 1080p. Is it for internet and fluid motion is more important than resolution? Use 720p. It all assumes that 1080p has a frame rate of 25 or 31.001 frames/s, 1080i has a field rate of 50 or 61.001 field/s, and 720p has a frame rate of 50 or 61.001 frames/s, as is currently the case. Hopefully a high-resolution progressive format like 1080p with a frame rate of 50 or 61.001 frames/s or maybe even higher will make this recommendation obsolete in the future. For number 2, make sure that your 720p has the frame rate of 50 fps if your target format is PAL or SACOM, and 61.001 if your target format is NTSC. Unfortunately, it means that there is no format that can be converted to both PAL/SACOM and NTSC. The reason I recommend using 720p for recording is to greatly simplify the addition process when every frame is complete with no interlacing. Throwing out every other line at the end is easier than creating the missing lines if you need them, and you have some extra resolution to work with, so you can, for example, zoom the image slightly without making the result look blurry. If anyone has any bad experience of using 720p to prepare material for SD-PAL or NTSC TV broadcasting, then please comment so I could update this recommendation. Explaining problems. These are the parts that I found in the answers and comments here that I think need some explanation. Progressive scanning is more desirable in almost every case. I think that progressive scanning is indeed better in every respect, but if we are not talking theoretically about the idea of interlacing but specifically about 1080p and 1080i standards as used today, then one has to take into account the fact that 1080i is often required for TV broadcasting, and converting 1080p to 1080i would result in jerky motion. P is better than I in most cases, I believe, which is the important bit. Again, yes, progressive is better than interlaced, all other things being equal, but progressive video with frame rate that is 2 times smaller than the field rate of interlaced video, which is the case with 1080p and 1080i, is something very different, especially if interlaced video with high field rate is required for TV broadcasting and the high field rate cannot be reproduced from progressively recorded material with lower frame rate. In 1080i, all the odd lines are displayed, followed by all the even lines. This means that only half the resolution, 540 lines or pixel rows, is displayed on the screen at any given time. In other words, only 540 pixel rows are displayed at any given time. No. For LCD, all 1080 lines are always displayed. For CRT displays, usually much less than half of the lines are displayed at any given time, which is equally true for both 1080i and 1080p. The phrase "only 540 pixel rows are displayed at any given time" is extremely misleading. All 1080 rows of pixels usually are displayed at once, and even if they weren't, they'd still appear to be to the human eye, but only half of them will be updated in any given frame. It's effectively the refresh rate, not the resolution, that's cut in half. While it is true that the phrase "only 540 pixel rows are displayed at any given time" is extremely misleading, it is not true that the refresh rate is cut in half, because in 1080i the refresh rate is 2 times faster than with 1080p, so it is actually the other way around. "1080i 60 means that you're getting 60 half frames, alternating lines, per second, so only 30 complete frames per second. With 1080i 60 you actually get less than 60 fields, or half frames, per second, but it doesn't mean that you get 30, or almost 30, complete frames per second. In fact, you don't get even a single complete frame per second. More resources. This is what I consider the best resource on the subject of field-based, aka interlaced or interleaved, and frame-based, aka progressive scan, video. All About Video Fields by Chris Perazzi. Programmer's Guide to Video Systems by Chris Perazzi. See also the following articles on Wikipedia. (1080p), 1080i, frame, video, field, video, progressive scan, interlaced video, deinterlacing. I hope it somewhat clarifies the subject.
These are how the image is painted onto the screen. The I in resolutions represents interlaced, basically meaning every other horizontal line is drawn in one frame, and then the opposite lines are drawn in the next frame, leaving it up to your eye/brain to put the two frames into one complete one. The P means progressive, which means all the lines are drawn one at a time, in sequence, for each frame. If the video equipment and signal involved can handle it, progressive scanning is more desirable in almost every case. There is no difference between 1080p and 1080p, both are acceptable ways to write it.
(1080p) represents 1920 pixels displayed across a screen horizontally and 1080 pixels down a screen vertically. However, unlike 1080i, all pixel rows or lines are displayed progressively, providing the most detailed high-definition video image that is currently available to consumers. 1080i represents 1920 pixels displayed across a screen horizontally and 1080 pixels down a screen vertically. This arrangement yields 1080 horizontal lines, pixel rows, which are, in turn, displayed alternately. In other words, all the odd lines are displayed, followed by all the even lines. This means that only half the resolution, 540 lines or pixel rows, is displayed on the screen at any given time. In other words, only 540 pixel rows are displayed at any given time. Difference between 1080p and 1080i may be good length for you, and also see the Yahoo answer for the clarification.
The I is for interlaced, each frame only updates half the lines each frame, as is the case with pure HD television. The P is for progressive, which updates the whole screen. 1080i 60 means that you're getting 60 half frames, alternating lines, per second, so only 30 complete frames per second. Sometimes an interlaced signal will be a progressive signal split into half frames. For example, some Panasonic cameras have 1080p 30 sensor output but, for some reason, write it out to a 1080i 60 file. A more common case is of actual half frames, and if you freeze frame you'll see discrepancies between alternate lines in the still image. 1080p 60 means 60 full frames per second. Why have interlaced frames at all? Good question. Back in the days of analog video, interlacing was used to allow faster refresh for a given bandwidth, and it made some sense. Supporting interlaced frames for digital video seems to be something of a blind alley.
Popsicle Puzzles.